Grüß euch miteinander. Ihr könnt jetzt schnell sagen, wenn der Berndeutsch weht. English? Alright. Maybe between you and me, but not for everybody. It's too embarrassing for me. Okay, so I'm going to go in English. If there's any questions regarding words I say, just ask me. I speak Swiss German, so I can translate. Thanks for showing up in this sticky room. My name is Till Bai. I recently finished my time at ETH Zurich, and together with Soldier Rightman in the tots back there and a couple of other friends, we have built software development platform. But before I explain what that is, I'd like to show you this picture. So if you're looking at this picture, your brain computes approximately 10 million calculations in 1 second. And if I tell you software engineering versus the human brain in words, I get to maybe put 2 words in 1 second. So in the communication that I try to make with words to you, I have somewhat a bandwidth problem as compared to the image that you are looking at. And if we are talking about very complex and error-prone activity like software engineering, we have to make sure that the communication uses all of the bandwidth in order to understand each other. So the tools that we use to manage our software development process have to visualize as much as possible of this process, so everybody in a team really understands what's going on. And one reason why teams, small teams nowadays are able to build bigger and bigger software systems, one reason for that is because they are using tools that visualize whatever they do much, much better than the tools that they were using previously. And for this set of tools, or this family of tools, is typically referred to as being software development platforms. What are those? Well, basically they are just a collection of things that developers like to use in order to maintain and to manage their process. Right? They develop software, somebody uses it, and in order for somebody to use the software has to be written, compiled, published, and then the users have to have some sort of possibility to give feedback to the users, to the developers again. So let's look at the different parties in this process. First, look at the developers in order to understand what a software development platform needs to be doing. So developers nowadays, they work from the army. They work globally distributed, not in the same spots. They have a laptop, and laptops are powerful enough so you can basically program in the train and then check in code as you get home, and you can pretty much work everywhere. That's pretty nice about our job as developers. Developers have different cultures, so again the communication becomes more difficult because people simply just, you know, Mr. Rightman is from Basel, I'm from Bern, and sometimes we just don't understand each other, right, because we have a different culture. So everybody uses different technologies. I use, you know, the previous version of Eclipse. He uses the latest version of Eclipse. He's on a Mac, I'm on a Ubuntu machine, so on. Typically, we also don't work on only one project at once, but we work on multiple projects, so we need to be able to use the tools to support our context switch from one project to another, because in one project we might be doing this and that, and on the other project we might be in an integration step or in a refactoring step. So there's multiple projects involved. Developers change and move, you know, they say, well, I've had it with the weather in Switzerland, I want to go to California, so see you, I'm leaving. And then when they develop, they use different methodologies, they work ad hoc, they have no time for endless process and lengthy requirements sheets and all that sort of annoying stuff, right? It gets on our nerves. But as developers, we like to adopt to new tools. So the software development platform that we are using has to be able to leverage new tools because, 10 years ago we were hype if we were using CVS. Nowadays, if you're not using Subversion, you're kind of lame. Or if you're really on the edge, you're using JIT or Mercurial or, SVK, whatever. So software development platforms that visualize this complex ecosystem of tools that interact, they have to take into account all these things. And this is only the attributes of the developers. Then we have, of course, the methods that come into play when we develop software. There's a myriad of different software development methods. I hear that in Bern there's a lot of work going on for government agencies, and government agencies, they still like that waterfall model, right? So you first have an analysis phase, and when you complete the analysis phase, you move into an implementation phase, and it's all really sequential. If you move to more high-tech fields, like if you look at the way Google develops software or IBM develops software, they have other methods. And in a way, a software development platform doesn't really have to pay too much attention as to what method you are using, because in the end it has to be able to work with any method that you are using. It has to perform a couple of things. It has to make information accessible. It has to allow you to track changes, and it has to allow you to gain an overview, right? You come in on Monday morning and your Californian co-workers, they have worked late on Friday evenings, and you come in and you want to see what's happened. So you don't have time to read through every commit log and every email that has been going over the message boards. So you need some sort of way of filtering all the information that comes in, but you also need a way for other people to point out important information if there is important information that you should be aware of. All this to get an overview, again, to increase the bandwidth of communication. In order to collaborate, you want to be able to concurrently edit documents and, maybe even share an editor with multiple cursors, a bit like Etherpad or Google Docs or stuff like that. And of course, asynchronicity in the development process is important if you have people working in other places, in other time zones. And ideally, the development methods should also provide you the possibility to integrate new tools. I mean, who would have thought 10 years ago that wikis would become so important as they are nowadays? So this much for the definition, what a software development platform has to do and why it has to do it. Now I'm switching to the platform that we are developing at ETH. The platform is called Origo, which is Latin, means source, and the philosophy behind the platform is it tries to make everything as simple as possible, and it tries to be able to integrate new tools seamlessly. So here is the functionality of the platform. You have the usual suspects like source control management. We also decided to host closed source projects because we were at the university and we had those researchers that wanted to collaborate on research papers, so they really had the strong requirement that they wanted to keep their stuff to themselves before the publication, right? So we also allowed them to create closed source projects. And then, the usual stuff that I mentioned before, you have an issue tracker, you can edit wiki pages, blogs, forums, there's a chat server, you can create communities that range across different projects. And then what I marked green here is what is more related to my claim from the beginning of the talk about the visualization. So I'm going to go into more detail what concerns statistics and work items. Other functionality is release management, file mirroring, user management. We have an API, so you can integrate the platform into whatever scripts and tools that you might have. And we have written a bunch of plugins. Notably, Mr. Reitman has written a very nice Mylan plugin for Eclipse that seamlessly integrates Mylan into Origo. So let's look at the stats. That's visual, right? You see How many open issues, how many closed issues? Well, actually here the scale is a bit off, so you have 400 closed and maybe 110 open issues. Over here we have the work items. I'm going to describe work items in more detail in a second. Commits versus open issues and download stats and all sorts of other statistics. They give you an overview of what's going on. Now that's for an open source project, right? That's really interesting. If you work in a closed source setting, the downloads might be not that thrilling because nobody's really able to go and download directly from your project site, right? Second thing that visualizes what's going on are the work items. The work items are basically atomic tokens of actions that happen in project life. So there are work items that are being generated per commit, per bug report, per release, on every wiki page change and comment, on every blog post. And they are then distributed to everybody on the project using RSS feeds. On a web page, you have a dashboard that shows you all the work items that have come up for your project. I'm going to show that later on. You are getting emails if you want to. So, like, you know, the standard Subversion commit email. You also get an email with a diff for your wiki page, or you get an email if there's a new release and so on. So again, multiple channels for distributing the information to all the people that are working on the project. The Ide plugins are also able to go and grab the work items over the API. And then we have a bunch of contributors that have written widgets for Vista, I think, and for Mac OS that also visualize the work items. So now, fine, we have a bunch of tools that developers like to use. We have file servers, we have a backend that provides all the functionality and weaves the things together. I'm going to show the architecture of the platform in the second part of the talk. But here's just a screenshot of the web front end that ties all these tools together. So that's basically the self-hosting Origo project. That's our project page for the Origo project, but that's a bit boring. So let's move here and try to make a bug report using... Does that work? All right. So the movie is showing how you can use the Mylan plugin to create bug report, and then you will see the work item that is generated on the platform. So this is just Eclipse that has our Origo plugin loaded. Here you see again work items. Now we connect to the Mylan tool that shows all our issues, and I think I'm going to update an issue on... Yeah, exactly. The OpenID login functionality was broken, so... So basically from within your IDE, you are reporting an issue that is then published on the issue tracker of the platform, and this happens over the API. So if you are using another IDE, you could also just connect it to the platform over this API. That was pretty useless, and I'm submitting it, and now here it showed up. So that's the comment that I submitted for this bug. And if I now go to my dashboard where I see all the work items on the Origo project, I should have a new work item that popped up with the updated issue report. And obviously these links would then take you to the issue tracker where the thing had been reported. Okay, now we can become a bit more technical. One might ask, why has ETH decided to implement a new software development platform? Because after all, there are plenty of platforms out there. There's SourceForge, there's IBM Jazz that is recently launched, and there's Microsoft Team Foundation Server, there's CollabNet that has a platform, there's GForge. All in all, there's about 40 different platforms. But back 3 years ago, when we were planning the platform, there was no single platform that had a distributed architecture that would scale across multiple machines, just the way Google has organized their servers. And there was no platform that had an API. And we really wanted to have an API because we thought it's retarded to not allow developers to write their own tools that interact with the software development platform. I think to date we have around 120 API calls, if I'm not mistaken, around that. Here's one for adding a release. We implemented the API with XML RPC. We were thinking that it's probably the easiest protocol for anyone to implement. So if you wanted to write your own plugin that works with the platform, the only thing you would have to do is create an HTTP request that ships some XML to the platform. Here's screenshots of the widgets that use the API, and now we come to the interesting part, to the architecture. Now that's really different from most of the systems out there. Down here in the lowest layer, you see we have a bunch of servers. The public Origo instance at ETH uses 5 servers. And then we have a backend that's basically abstracting the controller and the model, if you want. So the model being the database and the file system, and the controller just the nodes that know the use cases that can be executed on the platform. The backend is built using an ESB based on Apache MQ, and those nodes, they could run all on one machine or they can run on 20 machines. It doesn't really matter. The only way you can interact with those nodes is over XML RPC, and everything you have seen uses XML RPC. So the web page, that's the web page here. So the web page is built using Drupal, and then we have a theme, a custom theme called Bluefish that mimics that project layout that you saw, and then on top you have the URL that brings you there. So blah 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 project.origo.ethz.ch. The web page uses XML RPC to interact with the backend. The Eclipse plugin uses it, and all the other scripts that anyone might use. And I was referring to the ability of the platform to integrate new tools in the beginning. We don't want to write our new subversion, right? If a new configuration management service comes up, we just want to be able to wrap it. And using this ESB backend built with Apache MQ, we can do that. So at the moment, we have different types of nodes that build this backend. So we have a node that can simply send email for the work items and for user registration. We have API nodes that listen for the incoming XML RPC. We have a node that wraps the subversion service. So whenever you create a new user for a project, this triggers the subversion server to record the access control credentials for this user in its own access database. The business nodes that contain the application logic, and then the storage nodes that abstract the file system and the databases. And if we wanted to, let's say, implement a voice over IP node, we would just add another one of those and start it on one of the servers. So are there immediate questions to the architecture right here? I think we have a little time. Okay, so we're nearing the end, so let me show you a bit what's happened. So as you can imagine, it's just around 12 people that have implemented this platform, and we didn't really, we are engineers, right? We have no talent in doing any marketing at all, so we didn't do anything, and just by that we happen to have users, and that's pretty cool for things that are being done at ETH. So it's the first quarter of 2009, and we're growing rapidly. Statistics for the work items, what's really making me happy is that by far the most work items are commits, so people are really developing software there. And with that, I would like to conclude. So the future, we're partnering with Dell for an Origo appliance. We would like to integrate tools that allow you to test your software automatically, code coverage tools, voice over IP, and we might even start a project with ETH for formal verification of the code that you're hosting there. All right, that's it. So if you have any questions, send me email or speak up now.
Okay, thank you very much. If you have questions, you can ask them now, and please say quick who you are.
Frank Bamali. What I saw, you haven't taken the life cycle from the beginning to the end. I mean, there's no requirements engineering or gathering in your platform, no testing either. Is that right?
That's right. So we leave all that to the team that uses the platform, right? If you want to do requirements engineering, go ahead. You can do that. You can document your requirement listings using wiki pages. You can create as many wiki pages as you want. But we are not enforcing any sort of process on the development teams. And the testing and also the continuous integration is also left apart because we don't want to go and maintain 7 different versions of GCC for 3 different platforms. You have to plug that in. We have, maybe you know, cruise control. So cruise control out of the box supports the Origo API. You can basically install a cruise control just the way you download it on their site. And whenever a build that is made with cruise control fails, an issue is opened on your Origo installation. But we separate these things. So what we do is we take the tools that are most commonly used together and put them under one hood. But everything that's platform specific for your particular project, we leave to the team. Yeah.
So, as I understand, you wrap a lot of tools into one say framework, one GUI. What I missed on the presentation is what kind of tools do you use? What tool do you use for a wiki, or do you have support for many wikis? What tool do you use for a revision control system? I thought it was SVN version, but okay.
So what we use is basically we try to use the most popular vanilla tool that is available. So for configuration management, we use Subversion 1.5. For the FTP, we use VFTP, yeah, I think.
Okay.
VSFTP, yeah. And for the mirroring, we use Mirmon. For monitoring the whole thing, we use Nagios, what you presented. For stats, we use the RRD visualization library by Toby Oettinger. Server behind it is Light HTTP and Apache. For the wiki syntax, we have integrated the complete MediaWiki rendering engine. So we basically built that into the Drupal wiki tool. So we have the Wikimedia syntax. The only thing that we built ourselves in terms of tools is the issue tracker, because when we started, what was the name of the more advanced issue tracker? It wasn't Bactilla. Bactilla was around for a bunch of years when we started, but there was another one that starts with M. But we weren't happy with it, so we looked at different issue trackers. Jira was nowhere to be seen, so we implemented our own. And we try to go for standard stuff as much as possible. The chat server is a Jabber server. Yeah.
And, another question, how open are you to external requests? Say if somebody goes to you and say, I'd like support for another wiki because my users are already used to another wiki syntax or another revision control system.
Well, it's all open source, right? It's MIT licensed, the code that we wrote. It looks maybe not like that, but we are a pretty small team. And we're pretty overwhelmed with the work anyways, so we're pretty open for requests, but yeah.
Do you make money? Do you charge, for example?
No. I mean, the appliance partnership with Dell is exactly to address this problem, right? Companies approach us and they would like to have Origo in their intranet, but they can't really host their code at ETH. So they want to have an installation for their intranet, and that's where we hope to eventually make some money, but at the moment we're not making any money at all. Yeah.
Okay.
Other questions?
I have myself also a question.
Okay.
What does I need for an environment when I want to deploy the whole your system? Yeah.
Sorry?
What I need for an environment when I want to deploy your system?
It runs on Debian stable. Yeah. So if you have one Debian stable server, you're able to set it up. Yeah. It's not as easy as that because you have a DNS you have to set up because you have those project name .blah.com or .whatever wildcard setups. You have all the different servers that come into play that have to interact well. But it's somewhat documented, and we have lots of painful experience to help others to set it up. Yeah.
Okay, thank you very much.
Thank you.